Hey everybody, and welcome back to another JASP tutorial. What I'm going to be doing in this video is showing you how to create a sampling distribution, or rather how to simulate your own sample following a normal distribution in JASP. Wow, that was a mouthful. So let's look at where do we go. The first thing that we want to do before we even open up our data set is to click on this plus button. So we can open up these modules, and this is generally where the folks that make JASP, this is kind of where they put some of their newer features. And so the distributions is a newer feature, came out in 2020, so depending on your version of JASP, you may or may not have it. But once you click it, it'll show up right here on this panel right here. Cool. Okay, so in order to do anything in JASP, you always have to have a worksheet open or your data open. So I'm just going to open up a random worksheet. So this is a data set that I was playing around with earlier. It has 810 variables, or 810 cases, excuse me. So lots and lots of data spread over several columns. Okay, so what I want to do here is to click on distributions, and this gives you a couple of options, or several options, about what kind of distribution you want. So far in class, we've only been talking about normal distributions, so that's where we're headed, but we could also look at the T distribution and the F distribution, both very commonly used distributions. The T distribution is very similar to a normal distribution. The F distribution is wildly different than either of those. So we're only going to focus on normal here, but if you're interested in playing around, you can find that stuff there. So once I click on normal distribution, it has already created basically an ideal standardized function, or standardized distribution. So it has a mean of 0 and a variance of 1, a standard deviation of 1. So we actually want to play around and see, we want to try other things. So what I'm going to be doing here is I'm going to adjust the parameters of this normal distribution, and you can do that over here. So you have all these different options whenever you click on distributions. The first is show distribution, and then you can change what the variables are. So I'm going to simulate this to basically be IQ. So IQ, as we know, has a mean of 100 and a standard deviation of 15. And actually this might not be right because I'm playing with the variance here, so it will be a little bit different than true IQ. So we may adjust this a little bit as we go along. So you may see that whenever I plug this in, the distribution disappears, right? It's actually just really, really far over here on the right-hand side. So you can look at right here, we have our axis, and it just goes from -3 to +3. So it's very, very restricted. We want to change that. Anytime you go to change it though, beware, you have to adjust the upper bound for it first. If you don't do the upper bound, it'll hit you with an error. Don't want that. It's just a waste of time. I don't know why they did it like this. So you want to put in the upper bound first. And I'm going to say the upper bound, let's say 130 or something to that effect. Here from the range, I'm going to do just 70. Okay, so that's going to show us this, and this is way too restricted. Now that I look at it, the variant, we don't have enough variance, so I'm going to add in the variance to this. So I'm going to try, I don't know, 225. Let's see what that does. That's a little bit broad, but that's cool. So this is kind of what the IQ distribution would look like. So the reason why I put in 225 here is because if you take the square root of that, it gives you 15, and that looks more like the IQ distribution in the US. So where we have a mean of 100 and standard deviation of 15. Okay, so we can use this and this part of JASP to look at different probability functions based on the values that we give it. So the way you want to do that here is you want to click on probability, and then it's going to give you the option to specify some values. So what can we do here? We can do, I'm going to do all the way from 115 to 100. Oops. All right. And so you'll see that it does it in real time. So I put in 115 here because it was going to give me an error if I specified that it was above 1. So, or if I were to change the lower bound to above 1, it would give me an error. So I plugged in 115 to 100, and so what this graphs out is here is the area of 100 to 115, and what is the probability of randomly selecting or randomly sampling one person in this distribution. What is the likelihood that one person is going to fall between 100 and 115 IQ? We see that is about 33%, 33-34%. So about a third of everybody is going to fall in between this piece. Now if we wanted to, we could look at 85, which would give us basically +1 and -1 standard deviation above and below the mean. Excuse me. And then we can see that it broadens it up, basically multiplies that probability by 2. And so now what we're saying is that it's roughly 2/3 likelihood of finding a person who is between 70 and 130 in their IQ. But we can play around with this a little bit more, where we can say we want to look at what is likelihood of getting 100 and below. And you'll see that's 50, right? Because I specified the mean and below. So because it's symmetrical, it gave us 50%. But if we wanted to change that a little bit, we could say what is the likelihood of selecting a random person from the US and that random person having an IQ of 115 or below. And we're going to see that that is about 84%. One thing to be careful about is that here in JASP, it doesn't always give you the precise number, it rounds. So if you need something to like the 1,000th decimal, you just have to rely on this 100th decimal rounding up estimate. Alright, so what we're saying is if we were to pick a random person in the US, what's the likelihood of getting that? And if we wanted to, we could put 130 here. Whereas, it's because as the IQ goes, I believe anything above 2 standard deviations above the mean is considered genius level. So what we're saying here is that what is the percentage of everybody in the US that is not a genius? And what we're seeing is about 98% of everybody is not a genius. So 2% out there, it might be you. And if you're reading this, you're thinking, yeah, it's me. That gives you that. But we can also do the reverse. So basically this right here looks at everything to the left of the specific parameter that you put in. You can also do the opposite, where you can look at everything to the right. And so here you're already seeing that what is everything to the right of 0? And we're saying that that's 1. In other words, it is 100% likely that you're going to choose somebody between 0 and infinity on the IQ, and that is probably not surprising. So let's put in 130 here, and you can see that the likelihood of getting 130 or above is 2%, which is exactly what this told us before, but we can play around with this so we can say what is the likelihood of getting 110 or above? That is about a quarter of the population. So a quarter of the population is above 110 IQ. Okay, cool. So that's an easy way of looking at these kinds of questions about, whether if you're looking at what's the likelihood of getting a certain, segment of the population, you can do that. All you got to know is just the mean and the variance for that. You can also input standard deviation, the t variable, the k variable. We haven't talked about those too much in class, but you can do that there. All right, so I mentioned at the very beginning of this video that if you wanted to, you could actually plug in, or you can create your own data, and you can do that by clicking on Generate and Display Data. If you do that, it will allow you to create a new column and in your data. So right here, I'm going to put IQ, and so I put IQ here, so the column is going to be named IQ. It is going to randomly generate 810 values that would fall along this curve. So it would follow along a normal distribution with a mean of 100 and a variance of 225, or standard deviation of 15. And let's do it. So I hit Draw Samples. If you click out of that, it'll create it. And just to make sure, I'm going to go back to our data. Moving all the way over here to the right, and now I have IQ, and so you can see that now I have this IQ variable. So all these new IQs that have been generated to simulate a normal distribution of 810 subjects. I can go over to descriptives, and in descriptives I can plug in IQ, and we can look at it very briefly. You can see that the IQ, that this variable 810 folks has a mean of 100.675. So it sampled 810 people, and because we have a very large sample size, that's going to be very close to 100, which is good. I feel good about that. If you're dealing with less than 30 folks, for example, then it gets a little bit messy. Then you got to watch out. So we got 100.675. So I feel good about that. Now, if I wanted to, I can go back over here and look at my normal distribution. And if I wanted to, I can play around with this, change it into a histogram, where you change different specific things. So I'm going to be looking at this in terms of IQ. that I have created, and this basically gives you the histogram for that. It looks kind of like a normal distribution. It's jagged, of course, but if we were to amplify this up to like 10,000, some of those bumps will get smoothed out. So that's pretty much it. If I wanted to, I could narrow this down to have bends of, I don't know, 15 maybe, and let's see what it does. Yep, it looks more normal. Bends of 10. It looks pretty normal to me. Okay, so other things you can do if you want to, you can try to estimate things like standard error or the confidence rate for these things. You can see that it's already given me this descriptive for the simulated data. So I have all that stuff there. I didn't even have to go to descriptive stats to do that. And you can assess the fit of it in case you are interested in doing that. So whether or not this fits a genuinely normal distribution or not. Other thing you can do that I failed to mention is that you can look at the simulated data, or this idealized data. You can do this in terms of looking at the cumulative distribution. So a very different take on the way that you show distributions, but it tells you the same thing. Or you can look at it in terms of the different kinds of parameters. So you can have it where it'll spit out different parameters for you. So here it gives us that. Or we can look at the explanatory text, which is a cool way of kind of explaining, like, here's what these different things do. So in case you ever get lost, you can click on explanatory text and it'll remind you a little bit about some of these things about normal distributions and things like that. Okay, so I think that's pretty much all you need to know. I always find this fun, playing around with this stuff, especially like kind of whenever you're creating the distribution. So play along with it, break out a z-table and check your scores here to see how well they line up and things like that. It should be perfectly, and that's how you do it in JASP. All right, thanks for tuning in. Bye.